So, solution of problem 3.1. Let's start with A. What we want to find here is the probability that a newborn will survive age 10, where we let T denote the lifetime of a newborn. So, goal in A is to calculate the probability that a newborn will survive age 10. Now, we actually have this pretty much given since this is exactly the same as the survival function, which they do give us in the exercise. So this is equal to 1 minus here. So we want to evaluate the survival function in the value 10. And this gives us 1 minus 10 divided by 110 to the 3/4. And fraction-wise, this is equal to 100 over 110, so 10/11 to the 3/4 power. And you can finish this calculation on your own if you want to find the numerical value. Okay, so B. In B, we want to find the probability that a newborn dies between ages 60 and 70. And as we mentioned in the first video, that is the same as wanting to find the probability that the lifetime of the newborn is somewhere between 60 and 70. And we can do that by using this formula here. So let's try to write that up. We want to find the probability that T is greater than 60 but less than 70. And this is equal to the survival function evaluated in 60 minus the survival function evaluated in 70. Now, a little bit of intuition here. Always remember, the survival function is decreasing from 1 to 0. So essentially, what we need to remember is the survival function is equal to 1 minus the distribution function. And as you might recall, the distribution function starts at 0 and increases steadily towards 1. Or maybe not steadily, kind of depends on your distribution, right? But the thing is, the survival function is decreasing and the distribution function is increasing. And the survival function just denotes the complementary event of what event you're looking at in the distribution function. It looks at the probability that your stochastic variable is greater than some value, whereas the distribution function looks at the probability that your stochastic variable is smaller than that value. So when we have something like this, f bar of 60 minus f bar of 70, what we have is one bigger number minus a smaller number. Not because this is wildly significant or anything, but it's just good to have in your head so that you don't mix it up and write f bar of 70 minus f bar of 60 and then you get a negative number. So just remember that. On the other hand, if we were to write this up with a distribution function, what we would write would be f of 70 minus f of 60. And you can get to this through various ways just by looking at the fact that this probability is the same as the probability that t is less than or equal to 70 minus the probability that t is less than or equal to 60. But also you can think about, well, f bar of t is 1 minus f of t. So if I plug in the value of f bar of t in terms of the distribution function, I turn around the signs and the ones cancel each other out. So that's just something to keep in mind while we look at this kind of stuff. Not because we need to use it now, but it's good to have both versions so that in the case where they give you the distribution function instead of the survival function, you don't go into a panic. Okay, so this is equal to 1 minus 60 110ths to the 3/4 minus 1 minus 70 110ths to the 3/4. And you can, calculate more of this fraction-wise or however you like, or you can also just get the answer off your calculator. It should be somewhere around 0.0853. So in this exercise, we get that there is approximately a 8.5% chance of a newborn dying between ages 60 and 70. So that's kind of the same as 1 out of 12 newborns will die between ages 60 and 70. Now note that does not mean that the rest of the newborns will survive past age 70. The rest of the newborns, well, some of them will die before age 60, others of them will die after age 70. So I know I'm talking a lot here and actually not doing that many calculations, but it's just really good to understand what this is all about. So that's why I'm talking instead of calculating. So that was A and B. I will leave C and D for the next video. See you in the next video.